so let's go through and talk about all the different types of hybridizations we can have. Now, the hybridizations are going to be based on the number of electron groups. So when we go back to our last chapter, we don't care if the electron group is a bond or if it's a lone pair. So all we need to know is how many electron groups. So if we know that parent geometry, that electron geometry, then we can predict what the hybridization is going to be. So all we have to be able to count is how many electron groups are on there, how many bonds, how many lone pairs total are there. So let's look at linear. So how many electron groups is in a linear? So remember, a linear was my AX2. Okay, so it has 2 electron groups. So if it has 2 electron groups, I need 2 things. The first thing would be an S, the second thing would be a P. So I'd have my S and my P, okay? So I'm gonna write that up here. We have 1 S, 3 Ps, and 5 Ds. So 2 electron groups, an S and a P. I take 1 S, 1 P, I mush it together, and that hybridized orbital is called an sp orbital. Okay? If I have 3 electron groups, I need an S, a P, and a P, because I only need 3. An S, a P, and a P. I mush it all together and I get sp2. If I have 4 electron groups, I'm going to have an S, a P, and another P. So I have those 4 orbitals, 1s, 3p orbitals. I mush them together, and that's going to make an sp3 orbital. Okay? Trigonal bipyramidal is if I had 5 electron groups. If I have 5, then I need an S, P, 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 and 1 D. So when I mush all that together, I have 1 S, 3 Ps, and 1 D. This isn't going to be an sp4 because I only have 3 p orbitals. I can't make up another p orbital. Remember, I can only use what actually exists, which is 1 S, 3 Ps, and 5 Ds, and I have to put them in that order. Then the last one is my octahedral, which has 6 electron groups. So if it has 6 electron groups, that's 1 S, my 3 p orbitals, and 2 Ds. Mush all that together, and I get an sp3d2 hybridized orbital. Okay? So if I know the electron geometries, if I know these, if I know how many electron groups are on there, then I can predict what the hybridized orbital would be. If I ask you what's the hybridization, this is what you would say. If I asked you what are the bond angles, the bond angles are the exact same as those parent geometries. Okay, so this was 180, 120, 109.5. This is 90 for axial to equatorial and 120 for equatorial to equatorial, and this is 90. Okay, so I know the bond angles for each of these because I already know the geometries from last chapter. All right, so let's talk about what this looks like. So when I say it's a hybridized orbital, what does this kind of look like in terms of hybridization? So if I have 2 electron groups, we said this was linear, so I would take the S and the P and I would smush it together. So in essence, this is kind of what it looks like. It's a P orbital, but it's got some S in it, and so the S in it kind of makes it look a little bit bigger than a normal P orbital. And it's a P going along that bond. So this is the central atom, has a bond going this way and a bond going this way. Trigonal planar has 3 electron groups, so this is an sp2. And so this sp2, you're end up having these little, looks like p orbitals on each of the 3 bonds. Here's your 120, but these p orbitals are going to be bigger than like an sp, okay? Because it has more p than it has s. This is like 50-50. This is 66% p and 33% s. So it's got a bigger kind of p orbital. All right, 4 electron groups we said was sp3. And so think about each of those p orbitals along the axis, but now they're kind of getting a little bit bigger. Same thing here, sp3d. You've got them along each of the axis, and same for sp3d2. So it's just kind of taking all those orbitals and smushing them together to make a new orbital. Okay? We're not going to get into this in too much depth, okay? Because this could get really complex really quick. So what we want to know is, well, how is this, what does this mean if I'm like trying to figure it out? So on the next problem, next slide, we're going to do a problem on figuring out the hybridization.